Kids, let me tell you a story about how 3 industrial engineering students helped us get all of your gifts to you on Christmas Eve by automating Santa's workshop. Christmas was getting closer, and the elves still were not on time with some of their tasks, including categorizing the gifts. While frustrated, they found a flyer of an automation lab of UPRM looking to help make processes more efficient using PLC, programmable logic controllers. They explained their situation. They needed to separate the gifts by categories for Santa but had limited amount of time and personnel. The students explained their proposal to solve this problem by automating the categorization using a PLC.
PLCs are versatile, small, cost-effective, flexible, and reliable. PLCs use a programmable memory for the internal storage of instructions of specific functions to control machines. In this case, we will program the outputs, the motor, the relay, the LED lights, and the alarm via ladder diagram language. The program will run while the data from the inputs devices keep coming.
The students had a plan and did a 3D model of the automation of the workshop that will be shown later on. Let's talk about it. There were 3 types of gifts. They proposed a station for each type of gift: pink, blue, and green. The pink gifts were narrow and short. The blue gifts were wide but short, and the green ones were pink, tall, and narrow. The identification station, represented by the low left red square, had 3 limit switches in the wall. Limit switches are electromechanical input devices. They let the program know when they are being pressed. So, if you locate 3 of them at specific locations on the wall of the identification station when you locate the gift in the station, which limit switches are pressed will be determined by the dimensions of the gift. A station for defective gifts was placed to store them separately. Faulty gifts were simulated with metals and a sensor. If 2 defective advantages are identified, a buzzer in the top left will alarm the elves. The gifts will be transported from the identification station to the corresponding station by the cart in the middle. In this case, the cart receives its direction from the code the students worked on. The central processing unit sends the instructions to the outputs according to the inputs of the limit switches across the workplace, 8 limit switches in total. 1 in each station and the base. These are touched by the cart, and as it moves, and they let the code know when the cart reached its destination to consequently have the code stop the motor of the cart. The 5th limit switch is in the cart. It is activated when the gift touches the switch after being pushed by the piston completely into the cart. The remaining 3 are at the identification station as was previously shown. LED are the output devices you may be able to appreciate when you see the student's model. Lights turn on when the CPU writes the data indicating them to turn on. There is 1 LED at each station that turns on if the gift is defective. The cart has 1 for the motor, relay, busy, deliver and return. The LED light at the identification station turns on when it's occupied. The other 4 are at each piston. Now, let's take a look at Lindamari's, Francisco's and Miguel Angel's work.